So parentheses, remember, parentheses for in the calculator. So the left parenthesis, and then I have R is not in the problem, in the calculator I meant to say, so it's 11x right here, and then plus 5. Close the parenthesis, don't forget, and divide by 10. At this point, as we did some time ago, remember second and table said, make sure the independent, only the independent is in the ask mode. And then go to second and table. We did this with amounts, principal deposited at such and such. We did this before. So, and plug in 5, and then 10, and then 20, and then 50, and then 60. 5. So this is the distance based on the speed of the car or the velocity. So d of 5 is 6. I have to write 6 feet. The measurement unit has to be there. If it's an abstract problem, you don't have any measurement units. But other than that, you have to make sure that everything you write has the measurement unit. So 10, 11.5 feet, 20, 22.5 feet, 55.5 feet, and 72 feet. Any questions so far? I can go to simply graph, and I can graph this function with the graphing calculator. It makes no sense. Why it makes no sense? So coming back to the domain for the linear function is, this is correct. However, we are talking about r, which is speed. Can we have a speed of negative infinity or negative 10,000 miles per hour? So this is okay for an abstract linear function. But for this, r has to be in the interval from 0, I hate to say infinity, but that's correct. So when I graph this function, I will only graph from 0 to infinity. Normally for linear functions, I always say from the beginning here, when we graph this, don't forget domain, table of ordered pairs, graph, range. For linear functions are the simplest possible functions. So I'm okay if you just find the x and y intercepts and don't create just for the linear functions. So the function d of r, I'm going to copy it here. It's 11r plus 5 divided by 10. So yes, I have to determine d of 0. That I have to determine. If this is 0, 5 divided by 10 is 0.5 feet. So when x is 0, not x but r, when r is 0, 0.5 feet, I'm going to just say this. And then I can choose any point that I already have. So can anyone give us this point? What point will this be?
0.5 and 6.
5, 6 indeed. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. So here's my point 5, 6 done. It will be incorrect to graph this part. So this is d of r. I always write the name of the line or the graph of whatever function next to it so I know what I graphed. You can write that this point is 0, 0.5. But I will not extend it. Is it incorrect? When it comes to the line, it's not incorrect. It's correct. But we are graphing based on the domain of this function. So this was okay for any linear function. However, because this is the speed, we cannot have a negative speed. back to sharing. Where is my book? Right here. So we either go back, if you want, to a finding the rate of change, which is really nothing. It's just the slope of the line. Or since we've done this already, we'll look at another word problem.
Is there any way we could do 82?
Yes, let's take a look at 82.
Okay.
82. Oh, so this is exactly the same.
Okay, I was just a little confused with explain why the domain should be restricted to the interval.
For the same reason, the domain is restricted here between 0 and infinity.
Oh, yeah, thank you.
Yeah. Okay, let's choose one more, or we continue with the next section. I really don't have anything else to say about these lines, unless you want to. The last section in this chapter is about nonlinear functions. We can start, we have, or we can choose another.
An average rate of change equation?
Yeah, it's the slope. It's a difference quotient, what we just did. If you want to choose this or this, doesn't matter. Which one?
76.
Okay. 76 is, which page is 46? Okay, so can anyone read the ordered pairs? I'm going to write them. So 2014, comma 3264 and 2008, 2063. Good. So in order to find the average rate of change, what do we have to determine?
First, you have to determine the slope.
But that is the rate of change.
Or you determine, like, so the first one, or sorry, 2008 would be your first, so x1, comma, y1, and then 2014 would be the x2, comma, y2. To plug into the first equation.
We don't have any equations to plug in. We only have to determine the slope. The slope is the rate of change. We're not asked to find the equation. We're asked to find the rate of change, the average rate of change. Rate of change or average between 2 points. Average rate of change between, there's a W in here, between point A and B. So that's the slope. Can anyone dictate?
y2 minus y1 over x2 minus x1.
Good. And then, anyone? Matt, are you with us? Not Nick, but Matt. Would you like to do this? Okay. So what do I have to write?
3264 minus 2063.
Okay, 26 is the same thing. y2 minus y1 over x2 minus x1. Very good. So let's calculate. So how much is 2063 minus 3264? I got negative 1201. And 2008 minus 2014 is negative 6. Okay, so then the slope is 1201 over 6. Good. Measurement unit. The measurement unit is extremely important here. Unit. The measurement unit has two pieces. One piece here at the top that comes from the top, and another piece here in the denominator that comes from the measurement unit of the denominator. So what is the top measured in? So let's go back to the problem. What is the top measured in?
Dollars.
Excellent. I have to write dollars. What is the x-axis measured in, or the values on the x-axis?
Years.
Yes, per year. So back to stop sharing. So please remember the average rate of change, like the difference quotient, like et cetera, et cetera. Any ratio has a measurement unit that is a ratio itself. I will not tell you that I'm driving at 50 miles. No, I will say I'm driving at 50 miles per hour. So the measurement unit from the top is in dollars, the measurement unit for the denominator is in years. So if we want to approximate this and divide by 6, I will say approximately 200.2. So approximately $200.2 per year. So please remember, this is extremely important. The measurement unit for anything that is not abstract, like what we had here. I have to write feet. And the speed in miles per hour and reaction time in feet. Always copy those so you don't forget the measurement unit. And this was 76 on 46.